Hey guys, welcome to our virtual star party for the 29th of July. I hope everyone's doing really well. My name's Matt, and tonight I've got Steve with me, who's one of our very good hosts. And if you've been up on a night sky tour with Steve as host, I promise you'll never have a bad night. Hey Steve.
Yeah, great, guaranteed. Guaranteed fantastic night with me on there. I'm not feeling any pressure at all.
Okay guys, well, if you're wondering what you've stumbled into, this is we're going to be showing you some cool stuff in the night sky. It's clear, people, it's clear. We actually got a clear night tonight. We're up here in our octagonal dome, and we're going to be using our Meade 14 telescope to have a look. But before we do that, what I wanted to do was I wanted to show you guys what Comet Mcnaught was. Unfortunately, it was a little bit too much light pollution up here earlier, and I had to set up. But this image here was taken by one of our very good friends, Ken Lawson, up in Geraldton on Saturday night, and it's a really cool image. And this is the foreshore of Geraldton, and you can see right here, lovely Comet Mcnaught. Unfortunately for us, it wasn't. It's not a naked eye object in the southern hemisphere, but considering we have all the cool stuff in the night sky down in the southern hemisphere, we've got to give the northern hemisphere a bone every so often, don't we, Steve?
Yeah, well, and back in Christmas 2008, we did get Comet Mcnaught, and I do recall standing on a balcony in the sporting club in Mundaring and looking at the comet near the horizon, and it had 60 degrees of tail. Yeah. So, yeah,
it's pretty awesome. I just moved back to Western Australia from New South Wales, and my parents had rented a property on the Perth escarpments, and it was 2 stories, and you could go out onto the decking on the second story, and there you had the massive big comet just left of the CBD, which was pretty amazing to see. So, guys, if you're ever up in Geraldton, definitely give the Geraldton Astronomical Society a call and see if they're doing anything, because Ken is part of the Astronomical Society up there. And also go have a look at his website, because he's a fantastic astrophotographer as well. So Ken Lawson Photography is definitely something to see here. So to start off the night looking through the telescopes, considering we've got a moon, what we'll be doing tonight is we'll actually be having a look at some planets and the moon as well.
Solar system objects.
Yes. So, to start our night off, we're going to join with looking at the king of the planets, Jupiter. So, Steve, what is Jupiter?
Jupiter is a gas giant. Now, within the solar system, we normally say that the Sun contains about 99% of all the mass, and Jupiter contains 99% of everything else. It's a couple of hundred times the diameter of Earth, and there's a ridiculous number of Earths that you could pour into it if you had that kind of godlike power. It's been the subject of a few space probes. Recently, Juno, which was orbiting it. Is it still orbiting it?
Yes, yeah.
It's still going. They're going to crash it into Jupiter in the not too distant future, but it's been going for a couple of years now.
Yeah, so they've actually extended it for another couple of years, and they probably might, considering how well it's holding up to Jupiter's radiation, I think it might actually get a couple more years as well, which would be fantastic, because Juno's job is to actually orbit in really, really close to Jupiter and see exactly what is the makeup of Jupiter. So up until only recently, we didn't know if Jupiter had a solid rocky core or if it had a liquid core. And what we now know is that it actually does have a rocky core. It's about 5 times the size of Earth, and there is next layer is metallic hydrogen, which is really cool liquid stuff that we can only just now start making in the lab. And then on the final top area is the cloud deck, which actually is about 3,500 kilometers. So when you have a look at the red spot, which unfortunately it's not there tonight. Hopefully, while we're looking at it, rolls around. But it's you're actually looking into Jupiter because it's actually a massive big tornado.
Yeah, and Jupiter actually revolves about once every just a bit under 10 hours. So if you don't like the look you're getting, wait a couple of hours. The red spot appears every night that you can look at Jupiter all night. You will see the red spot if you're patient.
Yeah. And guys, if you've got any questions, we've got our Discord channel where you can ask them. So if you need the link to join, there's the link in the description field of this video. And we're happy to answer any questions about what we're seeing tonight. You can actually really clearly see tonight here the banding on Jupiter. And so what you're seeing here is different jet streams going in different directions. And that gives Jupiter that nice banding that we get to see as well. And so most of Jupiter is actually hydrogen, and there is a little bit of helium, and then there's just trace gases like ammonia as well. So
yeah, ammonia, methane, all kinds of stuff.
Yes, all the bad stuff that we can't breathe. And it's named after the Roman god, top god Jupiter, and he's named after the Greek god Zeus as well. So it was the very first planet to form, and it actually is the reason why our moon is so heavily cratered on the backside, and also why Mars is so small. Actually, small. It really should be the same size as Earth, but there was a period of time called the late heavy bombardment, where Jupiter was eating a lot of material, and that causes drag, and so Jupiter actually starts to migrate into the inner solar system and gobbles up a lot of Mars's material, and also sends in a lot of material into the inner solar system, which would have been spectacular, but also kind of deadly at the same time. There was a lot of rock coming in, and
they didn't call it bombardment for nothing.
Yeah. And so, while thankfully for Earth, we have water, we have wind, which erodes a lot of these craters. Because the moon doesn't have an atmosphere, it preserves all the impacts that it's ever had. And so, when we did start sending probes to the to the dark side of the moon, as it's also called, we realized just how heavily it had been hit, and it was amazing. It's the only reason why it moved back into the position that it is in today is because Saturn formed where it was, and when they were in a 2-to-1 resonance. So for every one orbit of Saturn, Jupiter goes around twice, and every time they're on the same side of the Sun, their gravity would tug them out, and so Saturn actually saved the inner solar system from Jupiter, and in the process, Uranus and Neptune switched places, and they also think it kicked out another gas giant as well. So it was quite amazing what happened back in the day, and we think this could have if Saturn hadn't formed where it was, you could have ended up getting what we see in other star systems, which are called hot Jupiters. So yeah, and they even have moons as well. So I'm just going to try and let's see if we can find.
Can we pull up the Galilean moons?
Yeah, let's.
I thought I did see them earlier.
Yeah, let's go. Okay, we'll do here. And so this program's called Backyard Nikon, because we're using a Nikon D810 camera, and we're using now what's called the planetary mode, so that we can draw out the exactly. We can make changes. So let's have a look. So pause live view. Let's crack it up again. Ooh,
so for those of you with a bit of an optical bent, we're looking at a Meade LX200. It's a 350 millimeter objective lens, well, mirror really, running at f10, and we've got a Barlow doubler on it, so it's giving us an effective focal length of 7,000 millimeters or 7 meters. So that's the size of our telephoto lens. Yeah, as Matt says, we've strapped a Nikon on the back of it, and now we're taking little pictures to Jupiter.
Yeah.
Can I see moons now? I can, can't I?
So we've overexposed it so that you can start to see some of the moons, and there's all in all there's about 82 or so around Jupiter now. Jupiter and Saturn keep on competing to get the biggest amount of moons, but with Jupiter there's actually 4 main moons, and so they're called the Galilean moons after Giovanni Galileo, and we can actually see tonight right here, this one here is Europa, and this one here is called Io, and they're probably the 2 most interesting moons of the 4. The other 2 are Ganymede, and it is the biggest moon in the solar system. It's bigger than Mercury, and also it's got its own magnetic field, just like some of the planets do as well. Then there's also Callisto, which is the furthest moon out. It's the 3rd biggest moon in the solar system, and that they think that might actually have an ocean underneath, as well as Ganymede. These 2 here are particularly really interesting because Europa actually has a crust of an ice crust, and underneath that ice crust is more water than there is here on Earth. So, not saying space whales, but possibly if we're very good for Christmas, maybe bacterial life. So we've even seen geysers as well, and as well, just like we see on Enceladus. We actually were able to see that because when the Galileo space school, it actually was when Voyager went by, we were able to see take really nice photos of Europa, and what we saw was like tectonic plates, where you had massive chunks of ice that were rubbing against each other, and you could actually see these raised edges where we were able to work out that it was water actually coming up and then depositing onto the surface. And so that is definitely a really great place to investigate. We've got the Europa Clipper, which is being developed at the moment, and I think it's actually going to be launched on a SLS rocket, the Space Launch System, and should get there in the 2030s. Io, Steve, Io is the or Io is a pretty banged up moon, isn't it?
It sure is. Now, correct me if I'm wrong, that's the one with all the volcanoes, isn't
Yes.
it? Yeah. A lot of sulfur. Io's the closest moon. It's got an orbital period of 3 and a bit days or something. It races around Jupiter. It's also got an immense amount of tidal force on it. Saturn, there's a limit. I can't remember what it's actually called, but some guy came up with that.
Was it
the Roche limit?
Yes.
Yeah, where if a planet goes inside that, it'll break up. Io was pretty close to that. And what's happening is there's a great deal of heat and being generated by its being pushed and pulled and squeezed by all these tidal forces, and it spits out a lot of sulfur. They discovered those in the Voyager probe. the space probes that have gone there have found amazing things that you just cannot see from Earth with a telescope. And yeah, all of these, the Callisto, Ganymede, Europa, Io, they're all kind of weird, interesting places that we see when we're flying by or orbiting around.
And that was the one thing. So what happens is that not only does it get squeezed by Jupiter, but it's in a 1-2-4 resonance with Europa and Ganymede. So for every one orbit of Ganymede, Europa goes around twice and little Io goes around 4 times. And just like with Jupiter and Saturn tugging on each other to get them out to where they are today, this happens with the 3 moons. And so the reason they all have nice, interesting places to look at is because they all keep themselves warm by tugging on each other as well. So Ganymede has a liquid iron core which allows it to have its magnetic field. Europa has a hot core, which means that ice melts and you can have that ocean underneath. And then poor little Io has massive big land tides and also all these volcanoes because the center of the moon is so hot. It has something like 420 volcanoes, and some of them even move. There was, I think it's called Spica. And that was taken a photo of by Voyager, and then when Galileo went there in 20 years after Voyager, it had actually moved 20 kilometers. So imagine a volcano that moves a kilometer a year.
So what you're saying is the mountain was coming to Mohammed in that instant.
Yes, in that instance, yeah. And the land tides are amazing as well because they had. The land tides, you can actually start off where same level as sea level of where Perth is, the CBD, and then in about 5 hours you'll be as high as us here in the mountains, which are in the Perth Hills, which is about 130 meters or so. So, and then you're back.
If we had moving hills, we could be closer to the beach.
Yes.
Hey, we're about 16 minutes in, mate. Do you want to wallop over to Saturn?
Yeah, so we're going to go to Saturn now, and we'll say goodbye to Jupiter. Yeah. And so we'll just go back to our Nikon. So if you do want to have a read up more on Jupiter, have a read of one of the cool things that had happened was when they were looking at Voyager, when they were taking the photos, they actually had the other way. Yep. They actually had.
Just check the speed on that before you hammer it.
Sorry, you might want to go back and get it. I had it for a second.
Just press go to.
Got it. Here we go. We'll zoom it into the middle. So good. They actually realised they had a volcano on Io because there was one of the astronomers was working back late and looking through the photos that were coming through, and she realised that they saw a plume and couldn't work, and she realised it wasn't another moon. It wasn't couldn't be anything like that. But it actually had to be a plume, and that you can actually also see these 3 moons in the aurora as well because of the effects they have on Jupiter. So let's zoom in.
In completely unrelated news, that's the first time I've ever seen a woman wearing black nail polish. It was about 1980, or no, it might have been 70 something, 78, 79. Very avant-garde back in that day.
Okay, so we've got Saturn here. Say hello to Saturn, people. And we've got here the rings as well. You can kind of see where Galileo thought it had ears.
Yeah, very confused.
Yes.
It was actually Christian Huygens, who a Dutch astronomer, who built himself a much larger telescope than Galileo had. It was probably a 6 or 7 inch or something. And he actually managed to make out the fact that it was a disk, which was a ball of a planet surrounded by rings.
And when you have a look at photos of Saturn, you'll actually see there is a main division in that ring. And that's called the Cassini Division, named after a 17th century Italian astronomer called Giovanni Cassini.
Yep.
And that was the name of the space probe that went to Saturn in the early... it left in the late 90s and arrived in 2004 and did 13 years of just amazing science. And then they burned it up in the atmosphere.
Yeah. And it was actually, Cassini dropped Huygens, which went to Triton and landed on the surface and discovered all those lakes and seas of methane, liquid methane. It was wild.
So the mission was a joint NASA and ESA mission, and it was done like that because ESA had issues with NASA, and they felt like the little brother and who wasn't being taken seriously, and so it was actually great because it staved off the mission from any budget cuts, because they could say, well, it's going to affect you in foreign relations with the US government, and so out of that we got a mission that was able to prove that there is actually a hexagon-shaped storm on the North Pole of Saturn, and it changes colour as well. It goes from a blue to a more yellowish gold colour as the seasons change. They were able to prove spokes on the rings of Saturn, which are dust particles that they think are either caused by electrical discharge from lightning on Saturn or micrometeor packs. And there's also they were able to see a storm in 2001 that went from the start and all the way around and back onto itself as well. So it's pretty amazing place. The rings, if you were to put them around Earth, would extend halfway to the moon, but they are only about 10 meters thick.
10 to 100. Yeah. We were talking about the Rorsch limit earlier, the limit whereby when something approaches a planet, the tidal forces are so great it will break up. Now, the moon that approached Saturn would have been mainly ice. I've got a little question here saying, what are the rings made of? And they are mainly water ice. And this planet broke up into 1,000 pieces. And the rings are actually ice and dust and rocks, each one orbiting the planet. If you jump onto Google and type in, Saturn images from or Voyager or Cassini or whatever, you will see the rings, and they look a bit like a vinyl record. They've got thousands and thousands and thousands of these little rings and gaps, and the resonances set up by the moons determine where in the rings stuff orbits and where stuff doesn't. And the Cassini Division, can we see the Cassini Division in this thing?
Not, no.
Can we blow it up a bit and see?
Let's have a look.
The Cassini Division is a dark line through the rings, and it's generally considered that it is the moon Enceladus, which actually sets up this major resonance where there's this fairly big part of the rings where very little will actually orbit, and there's a dark line in there. Somewhere else in the rings, not quite, hey?
No.
Can we stick it in the middle, maybe?
Yeah, let's have a look.
There's this fairly dark line in the rings, and if you want a better view of Saturn, one of the problems that we have at the moment is that as a set of subjects for live streaming, the gas giants are. That looks. You can make it out. It's fairly low on the horizon, and what you can see now is it sort of flopping in and out, as the atmosphere moves past it. If we could get rid of all this atmosphere, apart from the breathing and everything, and we'd be much better in the chair. We were like, "Ugh." But every now and again, what will come into focus is this gap in the rings, this dark line through the middle of the rings, and that's the Cassini Division.
Funny enough, we've just had Neptune's moon, Triton, just land on the Discord channel as well. Hello, Triton.
Hello.
How are you going?
Oh, excellent. Hello, Triton.
Yeah. And even the moons are amazing as well. So it has Titan, the second biggest moon in the solar system, and that moon is also bigger than Mercury. It seems like everything's bigger than Mercury, but unfortunately, no. These are the two moons that are only bigger than Mercury, and that is the only moon to have a dense atmosphere. And we nearly didn't get to go to Uranus and Neptune with Voyager 2, because had Voyager 1 not got really good data from Titan, Voyager 2 was going to have to go down the same path. And
that would have gone upwards out of the plane of the ecliptic.
Yes. So the reason they actually designed the Cassini mission to have a very special set of cameras, because Voyager 1 couldn't penetrate that dense atmosphere. It looks like just a giant, big, yellowish gold ball in space.
Yeah,
and
I remember
that's
that.
because it's mostly made up of carbon monoxide. But this moon is amazing. It actually has its own weather. It's so cold that the system isn't controlled by water.
We've been requested to zoom in again.
Zoom in again, no problem. We'll do that again. It's actually controlled by liquid methane, and that is it is an absolutely amazing. We've been able to see with Cassini. We've been able to see lakes and seas of methane. Liquid methane, and we've been able to see it rain. We've been able to see waves, even though they were 1 centimetre.
1 centimetre waves.
Yes, they were. We were able to see gullies, and we've been able to see dunes as well. And one of the concept missions coming up is to go back to Titan and actually with a drone, but not just a small little drone. This thing is going to be the size of a 4-wheel drive, and you'll be able to fly around because it's only 1/16th the atmosphere or so of Earth. So you can literally fly by flapping your wings. So if you're a massive big fan of extreme sports, this is one hell of a place to go to. It's very, very cold. You're going to need a lot of insulating gear. But eventually, hopefully, we can go there one day. We think that is what Earth looked like at the very beginning as well. And so it's just an amazing place. We've got Enceladus, which we thought was just a massive big snowball the size of the UK, and Enceladus basically said, "Yeah, I'll prove you wrong." And so what we saw were tiger stripes, these blue tiger stripes on the southern hemisphere. As Cassini was flying by, they saw this massive big plume of water just pouring out from the southern hemisphere. Yes, thermals, yes. So these were massive big geysers. And so they thought there must be a big pocket of water under the southern hemisphere. And what they were actually seeing was an entire ocean underneath the ice crust. And out of that, you're able to... what they think is that there are what's called hydrothermal vents in the bottom of that of the moon, where the actual water meets the moon itself. And that because of the tidal forces of Saturn, there's a core inside the moon which is really hot, and that is some of that heat is leaking through these hydrothermal vents, or what we call here smokers, and that is the actual that is the cause of these massive big geysers. As we actually managed to fly Cassini through through the plume, and we were able to see the different makeup of that water, and we saw hydrocarbons. So we know that the water, the actual ocean, is not only touching the ice, but it's also touching rock as well. So it is going to be is another fantastic place to find. The funny thing is that there's been, up until only about a decade ago, there's been the Mars Coalition who wanted to get all the missions to go to Mars. And now we've got their own Oceans World coalition, so that they can fight to get more missions to not only just Europa, to Enceladus, but also to Pluto as well, because we think there is an ocean underneath Pluto. So as the motto says for finding life, head to the water. So
that's actually a pretty amazing image. Now I'm looking at it.
Yeah,
if you
can actually see some banding.
Yeah, you can see some banding just up there. Yeah,
there's some banding here. The pale yellow colour actually comes from ammonia crystals high up in the atmosphere as well. So
Saturn, like Jupiter, it's a very, very large ball of gas, and it is rotating very, very quickly. So the forces, the kind of centripetal forces around the atmosphere by this enormous amount of rotation, you can imagine the speed of this thing. That the Earth moves at 1,000 miles an hour at the equator, or 1,600 kilometres an hour. These things are moving at, like about 30,000 kilometres an hour at the equator, perhaps even faster. I haven't done the maths recently, so I could have done that before we started, but I didn't think of it. And so this enormous mass of gas whirling around creates these tremendous storm areas, and you can see that the atmosphere gets churned up around the north and south equatorial bands, which is what you can see on Jupiter. Of course, it's hard to see a southern equatorial band on Saturn because the ring system is getting in the way.
So one cool thing, because it moves so fast, it's actually a flattened ball. And one cool thing is that out of so many is that it's the least dense planet in the solar system. So if you had a bath big enough, this would float. So it would be some gigantic alien's bath toy.
But if I can make a dad joke here, Saturn would float in the bath, but it leaves a ring.
Yes. Yeah. So it is definitely one of the highlights to come and have a look through the telescopes. I don't think we've ever not had a wow when people see Saturn.
It is a great sight, and over time, at the moment, as you can see, we have amplified this to ridiculous extent. However, the atmospherics is are really seriously interfering with it. And when are you going to have a go?
Try and see the moon.
Overexpose it, and we'll see some moons.
Yeah.
But when looking at it through the instrument, what you tend to find is that over a few seconds it will go still and sharpen up quite remarkably, and it is a beautiful sight. For my money at the moment, I think Jupiter is the bee's knees, particularly if you've got a red spot. The other night on Jupiter, not only did we have a red spot, but I think, was it Ganymede that was casting a shadow? One of those moons was casting a shadow, and you could see a little black dot on the surface of the planet, which was like an eclipse caused by one of its moons. Yeah. It's really quite an amazing thing.
We've got a question here saying, if a foreign body passes through the debris in the rings, does it semi-permanently deform it, or is it continuously shifting? Well, they do have shepherd moons within the rings, that are moons that are basically stunted from growth by their own gravity. And so you can, and they do like a merry-go-round. They go up and down as they orbit around Saturn. And you can get these disturbances in the rings. So you can imagine flying across the rings, and you come up to one of these shepherd moons, and you see a rise of 200 meters of ice and dust. It would be an amazing scene to see. But if a foreign body did hit it, it would disrupt it. It would probably be continuous. Over time, it would the effect would disappear on it.
Yeah. The other thing to remember about the rings is they are quite ephemeral. By which I mean that means they're not there for very long in astronomical terms. I mean, they will be there until our great-great-grandchildren's great-great-grandchildren are old people, and they will still have plenty to go. But the rings have only been around, I think, for about 20 to 30,000 years maybe, and it looks like they won't last for more than about 100 or 200,000 years. And then that they will gradually dissipate. It's been witnessed that.
You'll still get particular rings like the E ring, which is fed by Enceladus, which is water ice, but it's a fairly diffuse ring. So you'll get Jupiter has 4 rings, but we can't see them because they're just too diffuse. You have to be there and taking a long exposure to be able to see them.
We have a question: how do you measure the density of a planet? And the way that you measure the density of a planet is to calculate the speed of the moons around the planet and their orbits. The more dense the planet, or rather the greater the mass of the planet, the faster the moons will orbit, because it's got it's to do with the gravitational constant of mass by mass over the distance squared. So that gives you the force. Then you can actually measure the size of the planet, because we know how far away it is, and we know how far away it is because of a fairly arcane science called orbital mechanics. You measure the width of the planet as it appears to you, and hey presto, you've got a ball and you've got an approximate mass, so you can measure the density of the planet, because you know its mass and its volume, and that's roughly how we do it.
So, Steve, let's go. I think we're going to go to the moon next, won't we?
Yeah.
Yes. So while Steve goes and sets that up for us, one of the last things is that with Saturn is that it does have a nighttime, but that nighttime isn't as dark as it can be here in when we get away from light, because the rings actually cause what's called ring shine. That light that hits the rings can come back and lights up the dark side of Saturn, and so you kind of get a full moon conditions. So it's pretty. You can also go onto Google and you can actually see someone has done a CGI work of how it would look like at different locations on the world if it actually had if the Earth had rings as well. So
I don't know how this is going to go. I'm going to push this way.
So if you're going to hear some rumbling, it's not my stomach. It's actually
my stomach.
This is the octagonal dome moving. So
the entire dome moves. It's really hilarious. I think it's going to stop very shortly, and I'm going to have to push it the other way. Maybe.
So as we get this all organised, there is a couple of things coming up. We have the launch of the NASA's Perseverance rover on Friday. It's Thursday at 10 to 8 at night, and you'll be able to see it online. NASA will live stream it. And this is very much like the Curiosity rover that went there a couple of back in 2012. It's going to land the same way. It's got the sky crane, and as it hits the atmosphere, it hovers over the surface, and then then it will actually be winched down onto the ground as well. You might want to get the...
I might want to get this somewhere in the middle of the field here.
Oh, here we got some sun.
That should be pretty close.
Oh, very good. A little down. I think if you want to pass that here. Oh.
Hang on. Oh. Should go that way.
Yep.
Actually, I've got an idea.
Here we go.
Can you?
Yep.
Oh, you can just about see that, can't you?
Yep.
Other way.
Here we go. Oh, the other way. Yep. Here we go. Whoa.
Now, before you go anywhere with that, just hand me that, and I'll speed it for you, that you are not you're not moving at 1,000,000 degrees a second. Okay,
right.
that should
Here we go.
that should do for a little bit, and then we'll move it to 2x, and we can go roaming around the surface.
Yes. Okay.
And we can test each other out on the selenography. Look at that mountain range, baby. That is gorgeous.
Okay.
Oh wow, this craters and stuff.
All right.
I back in the day, many moons ago, when I was married, I brought my missus up here, and I showed her the moon through that big 24-inch telescope, and she said one of the most amazing things I've ever heard. She said, "My goodness, that looks like a place." And I think of all the things that we see, the moon is the most, place-like. It's when you think that Jupiter is something along the lines of 600 million kilometers away, and this is like 380,000 kilometers away. So it's something like 2,000 times closer than Jupiter.
So you can see here, this is the terminator line right here. So this is where night becomes day in this case. And so we've got it's coming up to first quarter. And so you can actually see some of these craters are still actually in shadow as well.
Just past first quarter.
Is it? Oh, okay.
Yeah, because it's a little bit more than a semicircle. It's a little bit round on the edge there.
Yeah.
See this crater here, which you can see that the shadow that is being cast is quite long, and this area of the terminator is very, very much like the evening when the sun is on the limb of the horizon, and all the shadows get really, really long. And it's the shadow, more than anything else, that brings out the features of the moon. If you are looking at a full moon has not really very much in terms of features, and it looks kind of flat. So a full moon night is not a great night for observing. Although I did look at the full moon through our 30-inch telescope a little while ago, and that was a pretty awesome sight, I have to say. Although I couldn't see very much afterwards.
So the reason we always see the moon the same side as the moon is because it is tidally locked. So we only see the one side. It does rotate, but the rotation is the same time as it does to make one orbit around the Earth. So, which is around 28 days, and we can see here even some more craters, and you can see some of these impacts, like this one right here. You've actually got a raised mountain in the middle, and that's where the impact has smacked the moon, and then a bit of it's come back up into the middle, and you can actually see some of these rays coming from some of the craters, and that's ejector that's gone into space and then fallen back onto the ground as well. So we'll go through. So this is I do love this part of the moon here. It's so heavily cratered. So we think the moon's has been created by an impact by a Mars-sized object called Theia, and it was early in the history of the solar system, and it was very chaotic. You have a lot of smaller bodies coming close by, and then disturbing each other's orbits. So it didn't take a lot for our Earth to get hit while it was in a shooting gallery, and this is so that impact caused a ring system just like like Saturn's, and it's over that period of time, over a period of about 100 million years, the moon formed from that material, and we believe this is the way it's happened now because when we went to the moon and we brought back pieces of the moon, especially the Genesis rock, which is called an orthosite. Oh, we've got the Sea of Tranquility there.
Yeah.
That's where.
Where's Tranquility based, do you know?
Tranquility, I think it's around this area here.
Yeah, I think that's where it was.
Yeah, and I think Apollo 17 landed around here. So from that, from looking at those rocks, we can see that while the moon's material isn't exactly like us, which means the moon didn't fling off from the Earth, because as the moon's receding, Earth's rotation is slowing down. If you bring it back closer and closer and closer, the Earth's rotation speeds up. So you can, there was a thought that maybe the Earth was rotating so fast it was flung off. Also, because it is so similar, it means that it couldn't have formed somewhere else and then being captured. It also meant that they didn't form together either, and so what it's lacking is heavy elements, especially like I believe it's like cobalt or stuff we use for our touch screens on our phones and that, and that's because that material fell back onto the Earth fairly quickly. It would also explain why Earth has such a large core, because you've got the iron core from Theia merging with the Earth's, which means it's fantastic for life because our Earth has such a strong magnetic field. It does protect us from the sun's solar radiation and also cosmic rays. So Mills, hey, how you going? Those lighter streaks are ejecta, what we call ejecta from meteorites that impact the surface. So you're seeing material that used to be on the moon that got flung up into space and then fell back down onto the moon as well.
Yeah, they're called rays. They're all over the place. And on the moon, unlike the Earth, where if something hits the Earth, particularly a large meteor, most of the stuff would go up into the upper atmosphere, and that's what we think killed the dinosaurs. A meteor in the Yucatan Peninsula, which caused a nuclear winter and wildfires all over the place. These things go up and they spread out and they just fall straight down because, of course, the moon's got no atmosphere. I'm just ranging around on the moon here because, well, let's face it, because I can. And you can see...
and I haven't actually given these guys this good a view as well with the Barlow on it. I've always had it. So we're getting an up close and personal.
Yeah, we were humming and hurrying about whether we'd leave the Barlow on, which doubles the kind of magnification of the telescope, and I did say, well, why don't we just do a little virtual tour of the moon? Here's a really good example of what we have here. We've got this crater in the middle, and you can see three main rays just wandering out from here, and these are the ejecta. This is a little bit blank here, so maybe this is a piece of higher ground, and you can see that this is lighter stuff here, and it actually spreads out over the Maria. This, I think, is Oceanus Procilium, but don't make bets on that because my selenography is rubbish. I really should sit down with a few maps and learn all this kind of gear, but to be honest, I've tried a couple of times, but it's like learning to read music. It just plumb evades me.
So we the next missions to Moon is actually called the Artemis program, and that's named after the god of the moon, a Greek god of the moon as well. So we've had Apollo, who is Artemis's brother, and who was the sun god, and now we're going to have Artemis, and So we should be able to see astronauts back on the moon sometime in the 2020s at least. So
it's a political will thing, I think. If we really wanted to, and we didn't kind of mind how many people died doing it, we could probably have people on the moon, by the end of the year, just about.
Yeah, it's.
I mean, the firepower exists to do it, and the crafts more or less exist.
Yeah, and we sent 12 people to the 12 people did walk on the moon, and we actually had 3 of them. Gene Cernan. We've got to restart the live stream again. Hang on, just give us a sec. Yep, just. And there you go. Camera.
Oh, right, the camera shut down on us.
Yes.
Yeah. I wonder why it wasn't moving anymore. There we go. And there's that lovely crater that we can see. That's quite a deep one. And there's this little ring of mountains here, and it's really quite a glorious little place.
So Jim Lovell, Gene Cernan and John Young all have been to the moon twice. And out of all together, though, there's been 24 people go to the moon. So hopefully,
and old Jim Lovell never got to walk on it.
I know. Yes.
How unlucky would you be?
Actually,
was he on Apollo 10 or 9?
He was on Apollo 8.
8. That's right. Yeah, that's right. He went around the moon, and orbited the moon, and then orbited again.
Yes, with a dire circumstances.
Yeah, a little bit. Yeah.
And the fact that he actually had to swap out his mission, which was originally going to be Apollo 14.
That's right.
Because they didn't think Alan Shepard had enough time.
Yeah, his ear infection or something.
And so, unfortunately, well, he still at least gets to see the moon up close. That would be definitely one of the amazing things that I'd love to be able to do. They brought back 382 kilograms of lunar material, of which 10 kilograms have been actually destroyed already in test labs. So that's...
We have to go back and get some more!
Yeah, but each country at that time was given a piece of the moon rock as well. The Apollo 11 astronauts actually came to Perth in October in 1969, and it was Michael Collins' birthday. So they had a big ceremony for the astronauts on the foreshore of Perth. I think Langley Park it was, and the young kids actually sung "Happy Birthday" to Michael Collins as well. So.
Do we currently have any minor captured moons? To be honest, I don't know. But I found it fascinating several months ago when I was reading about an artificial satellite that Earth had captured. And it had been in orbit for about 1.5 years before we discovered it or something. And I thought, well... there goes our early warning system for closely approaching meteors. Something's been in orbit for 1.5 years before we find it.
Don't worry, we'll find that with the Vera Rubin telescope, which was your favourite telescope, the Large Synoptic Survey telescope.
Oh, the LSST. Yeah, that's not going to be a good meteor finding telescope though. But the one that sits up, I think, in Kitt Peak, and has been there for quite a while. It's got this huge CCD array on it and takes, a photograph a minute of whole piles of the sky. They're really, really quite amazing.
So it is the biggest moon relative to its parent body,
by
which
a
is
long way.
It's about a quarter size of the Earth, so you can actually fit it in between Perth and Sydney as well. And it has 1/6 the atmosphere of Earth. That's why they had to jump around.
1/6 of the gravity, you mean? Not 1/6 of the atmosphere.
Yes, yeah. Oh, sorry. Did I say atmosphere?
Yeah.
It's kind of the gravity. Yeah.
It's kind of not breathing room up there. It's
There is a very, very minute atmosphere. So much so that it's insignificant. So that's why
it's molecules clinging to the surface more than an atmosphere.
I don't want to go.
Yeah, I'm staying.
Its average orbit is about 384,000 kilometres.
Yeah.
And but it can get as far as just over 405,000 kilometres and as close as 360 363,000 kilometres from Earth as well. So it's on a 5% incline as well. That's why we don't get total solar eclipses every time we have a new moon, and we don't get a total lunar eclipse when we get a full moon. So, and it's so bright, but it's only reflecting 7% of the light that falls onto it. So it's actually the same colour as coal.
Yeah.
So,
yeah. And it's also pretty close to the plane of the ecliptic now. If anybody feels like we're probably going to duck out in about 5 or 6 minutes. So if you are under a clear sky and you duck out, you'll see the moon. And as you move across to the east of the moon, you'll see Jupiter, which is a brilliant star-like object. And if you move more or less in the same direction, you'll see Saturn. So Saturn and Jupiter and the moon are all sitting in a line. They're in what we call the same plane, the plane of the ecliptic. And if you wait until, what time's Mars rising? About 11:30? Yeah, so around about midnight tonight, Mars will be up in the east as well, and the moon won't be set by then, and there'll be 4 objects more or less in a line. And that's a really, really interesting thing to observe, because what happened, of course, in the beginning was there was this disk of gas rotating around the sun, and all of the planets coalesced out of this disk. So all of the planets are more or less in the same plane. If you put them on a tabletop, have to be a big tabletop, obviously, about 80 billion kilometres across. But all the planets would more or less sit on the table with the sun. And so that means they all travel in a line. And that line is called the plane of the ecliptic. And traditionally we cut that up in 12 houses of the zodiac. And when the sun is in your sign, or let's put it this way, if the sun was in your sign about 600 years ago, because precession of the equinoxes kind of screwed that up, then that's the sign under which you are born. And what that means is that the sun was in your sign when you were born. That's what it means. That's it.
And then NASA has to go and cause controversy on Twitter when they mention that Ophiuchus is actually part of the zodiac, and that your star sign is the star sign before last.
Well, yeah, it is a problem, because I do trace the sun through the constellations of the zodiac. It's just my astrometric nerdiness coming to the fore, and those of you who have been on a tour with me will possibly know that that's what I do. Astrometrics is the position of things, and back in the day I used to work here, and that's what we did. We looked for positions of stars, positions of planets, positions of minor planets, and to a degree of accuracy that was just quite ridiculous. Nowhere near what we're capable of these days, and that kind of positional sort of accuracy that you see the sun in star signs. Yes, the sun is now in Ophiuchus, because the Earth changes, it rotates around like a spinning top, and the whole sky and all of it, in terms of where the ecliptic goes, where the sun goes, it all changes a little bit over centuries.
So before we go, what the local Indigenous people of Australia see the moon as a man, and so when he's the first quarter phase, he's eating, and his sons and wives give him food so that he can grow. And when he gets to the full moon phase, he gets too fat and asks his sons to go and find food for him, and they say no. And so he kills them, and the wives find out and come and hack at him with axes. And so he's running away, which is him progressively getting smaller and smaller to the last quarter phase. And then when he gets... so he tries to hide near the sun to try and survive, but unfortunately he's lost too much, and that's him becoming the new moon. And so he dies, for 3 days he's dead, and then he comes back alive, and he starts eating again, and that's him becoming a first quarter moon as well. So it's interesting to learn not only about the Greek stories of the atmosphere, but of the heavens, but also the indigenous as well, and even the Babylonians. They called the moon Suan, who is the goddess of the moon. So it's definitely really interesting to see all the stories of the different civilizations as well. All right, guys. So we've been doing this for an hour or so. Actually, before we go, Steve, can we see any liberation areas?
Libration areas tonight. The libration areas are always, I suppose not always there. Libration is where the moon slowly rocks backwards and forwards. It's always got its face turned towards us, the same face turned towards us. So we have the visible side of the moon and the far side of the moon. And it rocks just a little bit. So you will be able to see a little bit more of the moon. So if you bring it down, so this area here, if we take the mouse, if we take the mouse down here, this would be sort of a libration area where it moves backwards and forwards. But I can't tell you what it is. It's only about 2 or 3 degrees, so you probably wouldn't notice.
We're probably looking at the southern Artesian basin around that area there.
Yeah. So that's it, and you see the libration areas a little bit better in the full moon, of course, because you can see the whole moon. But again, because it's only 2 or 3 degrees, we'd be looking at sort of if you're looking at it from about there to the edge, that's about all the difference that it would make.
Yeah. All right, guys. So thanks very much for joining us tonight. Hopefully you've enjoyed the telecast, the live stream tonight. We do have down below links to our social media if you want to follow up and get all the astronomy knowledge and see what's happening here at the observatory. We have a quarterly newsletter that you can sign up for on our website, and that should be coming out in September, the next edition. It has full of amazing stories of space and what's happening here at the observatory and what we should be able to see in the night skies. And so and we also have our Patreon account if you want us to keep on doing this and help the observatory continue providing science outreach to the world. Please donate. You get some cool gear as well, and
like and share.
Yeah, and like and share also. If you can share this with your family and friends, we want to try and get as many people having a look at this. So thanks, guys, tonight. Thanks really for joining us, and we'll see you in another 2 weeks. We'll do this Wednesday, and at the same time, 7:30. Have a great night. Bye.
Ciao, babies.